Show for one-dimensional motion that a constant force leads to work is equal to 1/2 m times the quantity v final squared minus v initial squared. And you might notice that formula written there is really just a special case of the work kinetic energy theorem in the form of work is equal to a change in kinetic energy, but here maybe specifically written in a way that makes sense for one dimension. And it's fairly simple, I think, to show this for one dimension. It's a formal example, so I'm just going to pull it up here. It turns out maybe we already have shown this. We had a kinematic formula that we called the timeless formula. Maybe it should have been called the energy formula, because it turns out it has some deep connections here to energy. But in order to see that, I have to do some algebraic manipulations. It looks like I divided by 2 and then maybe subtracted, or maybe before I divided by 2, I subtracted by v initial squared on both sides, then divided by 2 to get this result. And then I'm going to connect that with a analysis of the work done by a constant force, and that force is in the same direction of the displacement. It's kind of tacitly assumed here. I hope that doesn't make anybody mad. I'm just kidding. F equals ma, right? So ma times d, mass times acceleration times displacement. But then if you take this AD and substitute what I got in here from the kinematic formula, that shows the relationship, because once you simplify that, that really is that change in kinetic energy. So in that sense, really, this result is kind of like something we already had, just algebraically manipulated into a new language. That being said, it's worth appreciating that this result actually holds for motions in higher dimensions than just one, and also for forces that are not necessarily constant. And it turns out proving that is a lot less trivial than this was.